pass to the next session, which you will present the different sections of the workshop.
So, if I'm right, would that be me now?
Yes.
I will share my screen then. Can everybody see the presentation?
Yes.
Perfect. My name is Witold Skrzypinski. I'm a senior researcher at DTU Wind Energy. I am currently involved in the IEA Task 41, the work package about the standards. This presentation is meant as food for thought for the upcoming breakout session, where I'd like to give you some introduction that will hopefully enable us to have a fruitful discussion afterwards. First, I will take up the words about the problem in the big picture, then suggest how we can solve it, say what has been done, specify problems, and ask you several questions. Three, namely. So, regarding standards, the problem formulation by the International Energy Agency is as follows, and this is in collaboration with international stakeholders. So, design and testing standards for distributed wind are a barrier to innovation and a source of increased cost of energy, at least as they are set up now. Certification of turbine models, especially those above 200 meters square, hinders bringing advanced technologies to the market in a timely fashion and is so expensive that it outweighs the value that it provides. So this is something that a lot of stakeholders say, that those are the problems to them. Now, regarding a possible solution in general, the IEC 61402 is a standard for small wind, which generally serves as a baseline for small wind turbines. Then this standard is open to revision in early 2020. The thing is that to allow a revision of the standard, efforts need to be undertaken now in order to understand key concerns within the existing standard, so get a little more specific in terms of what is to be corrected, then conduct the needed research to document the problem, and that will need to involve stakeholders from around the world, and then conduct research to allow justification for any potential revisions. And like I said before, in order for this to happen, it would require a strong international effort of both companies and research organizations. What has been done so far regarding standards in the IEA Task 41 is that 2 international meetings were held in 2019, one in the USA, which included many companies from USA and focused on the US standards, namely AWEA 9.1 and SWP. Then there was another meeting in Ireland with participants from Austria, Denmark, Germany, Ireland, Korea, Spain, and Taiwan. And that focused on the international IEC 61402. There are 2 additional meetings planned, but it is quite uncertain how this will work because of the coronavirus and the general shutdown. So now I will spend a couple of minutes and talk about specific problems that were already highlighted at the 2 meetings that I mentioned. So the number one challenge for international stakeholders, companies, is that meeting test duration requirements slows innovation and time to market. So the tests are too long, basically, and this is becoming a big problem. Number two is that the use of simplify loads methodology, SLM, made the design heavier due to high safety factors. So in other words, the methodology as such is currently too inaccurate, one could argue. Other than that, it does not address fatigue, which is a common failure due to for small turbines. And a initially proposed solution would be to create a simplify loads methodology for small vertical axis wind turbines, including fatigue cases. The other is that tower dynamics are not well addressed in the IEC standard. And a rather big problem is that power performance results are rarely matched at consumer sites, leading consumers to assume that small wind does not work, which is obviously bad for business. And one of the reasons for that is that a typical small wind turbine site has higher wind shear than that assumed, so other wind parameters. And this is something that probably should be addressed. Another quite often repeated problem is that medium turbines are kept out of the market for certified turbines because of the limit in the IEC standard of rotor swept area, being 200 meters squared. And a possible solution is that we need certification for small wind turbines up to 100 kilowatts or 500 meters square, and classifications or additional classifications for micro wind, which reduce the requirements. Another is that many of the current requirements, like normal turbulence model or turbulence intensity, do not reflect the reality that micro and small turbines are installed in, because the locations they are installed in are associated with high turbulence intensity due to human clutter. So those might be urban areas, for example, cities. And the last but not the least is that acoustic testing is considered the most difficult of all the small turbine test methods, and the output data are not self-explanatory to consumers. So those are 7 issues addressed by international stakeholders, and around those issues we are planning to build the international collaboration and conduct the necessary research. Like I said, this was aimed as food for thought for the upcoming breakout session, and at this session we would very much like to address 3 questions, namely, what problems related to standards, certification, legislation have you experienced in your daily business? Which of the listed issues are relevant to your daily business? And what would you like us to basically work on? Which problems would you like us to address? So I hope to discuss that after the break, at the upcoming breakout session. And currently, I'd like to thank you for your attention. I will stop the share now.
Thank you. And we have a question from Peggy.
Hi, Peggy.
Hi, it's just a very short one. The standard, the -2 standard, is not subject to rewriting, or what are we saying?
Revision.
revision by 2020, 22. It's already by 2021.
Okay.
And it's actually it's a subject by now, because you have to have the final version ready by 21.
Mm-hmm.
So by 21 you're actually out. The standard doesn't work anymore. Otherwise you ask for extension.
Mm-hmm.
So that's one date. And then the other thing is that I think it's very important that you look at the duration test and try to keep it, but maybe look at the wind data and the climate, and what kind of classification are you going for when you are doing your duration test. Because you can make duration test for another wind class and say this is a class 2 or class 3 turbine.
Mm-hmm.
And it's very important that you look at the turbulence, because we faced the problem we faced with small wind in Denmark, and turbines that crashed and fell down was not really the simplified load cases that were. It was actually the turbulence around turbines, and they were installed in very high turbulence, very close to buildings, and this is killing the turbines.
Wow.
This
Okay.
is the most important one. That was my advice.
Well, that is simply excellent to know. That is exactly why we're one of the reasons we're hosting this workshop, to get this kind of input. So you're saying that you wouldn't focus as much as the duration of the test, but more on the characteristics of the wind, and particularly its turbulence level.
Yes.
Mm-hmm. Excellent. Thank you very much. Regarding the 2021 issue, so there must have been a little mistake made, because this is actually the year that is stated in the documents we received from the task.
Yes, but that's a mistake made by the Americans. Mike, he put it up. If you look at the TC88 homepage, you will see the stability date. And that's where I made a copy from on my presentation.
Mm-hmm. Well, that's also excellent to know that it's
that's the official one.
Yeah. Thank you.
You're welcome.
Thank you.